Next up, I want to show the Scala enum type. And as I show here in lesson 67 of my book, Learn Scala 3 the Fast Way, an enum is an enumeration. And these are new in Scala 3. And we use these whenever we want to create a type that consists of a set of named values. And typically this is a small set or a finite set of values, at least I should say. And to show that some of these examples would be directions, so this could be north, south, east, west. Could be information on a computer display, so top, bottom, left, and right, toppings on a pizza, and other values. So for instance, this is how you could define the suits in a deck of cards. This is the syntax for that. And let me scroll that just up a little bit there. And so just to show the syntax here, I'll create an enum, and the name of the enum is suit. And then here you just list or enumerate the possible values for a suit. And when you think of a deck of cards, the suits it has are clubs, diamonds, hearts, and spades. And that's how we declare a basic enumeration. And so instead of watching me type, I'm just going to paste in some other enumerations here. So this is what directions would look like. You could also declare, if you wanted to create your own Boolean type, you would create an enumeration like that. And so this is how you do this with an enumeration. And then you would create functions that would work with these true and false values here. And as I switch back to the book, this is what I show on the next page is a little bit more complicated example. And this is for modeling a pizza store application. So a pizza, if you think about it, has a crust size, a crust type, and toppings. So I don't show a whole lot of toppings here, but this gives you an idea of how this could possibly work. And most pizzas have 3 different sizes, small, medium, and large. And they typically have 3 different crusts, although of course it's possible to have more. But you just enumerate the ones that you want. So I have thin, thick, and regular. And again, this list of toppings could go on for a while. So there could be 10 or 20 toppings, but that's still a small finite value. And then the way you use an enum, so now I pasted these into the REPL here. And the way you use these is you're first going to have to import them like that. And this lets me import these types, all of these types here. So when I say crust size dot star, it gives me direct access to these types right here, small, medium, and large. And that means I don't have to type crust size dot small all the time. I can just now just type small, and you'll see how that works in just a moment. Now that we have those declared, you can use them like any other type. So here I would create, if I was going to model a pizza, is what I'm thinking about. So I would do a class, or a case class in this case, of a pizza. And I'm going to say that a pizza has a crust size. So I'm creating a constructor parameter named crust size, and its type is going to be crust size. Then I'm going to create a parameter called crust type, and its type is going to be crust type. And then what you typically want to do for the toppings is I will create those, and I'm going to do this as a sequence of topping. And you can see that that creates the class, or pizza class, or again, in this case, it's a case class. And now the way you would use this is you would say something like val p equals, I want to create a new pizza. And to do that, I have to specify the crust size. So I want a small pizza, and I want a thin crust. And for toppings, I will just put on a sequence of cheese. And how about mushrooms? And similarly, if you wanted another pizza, and I'll just give this a different name. If you want another pizza and you wanted to make it a large and with a regular crust and just cheese, you would still have to pass in a sequence here. But that's how you do that. So it's a little summary of what we know so far. When you create an enumeration, you give it a name like that, and then you enumerate all the values for this. So that can be a crust size, crust type, topping, deck of cards, or whatever. And then what I do when I'm going to use an enumeration is I import all the types that I'm going to need, which I did here. And then what you do in Scala is you can just use the enumerations as types, just like I do right here. So there's a type, and that type right there. One other thing I want to mention also is that because in enumeration is a type, if I were going to start working on methods for a pizza, and let's say for some reason I wanted a get topping method, I would do it like this, and then you could declare topping as the return type here. So then it would be whatever code there is here. And the important thing I just want to show here is that, again, an enumeration creates a type, and then you can use the type not only here as types for constructor parameters and function parameters, but you can also use the type as a return parameter for a function. One other thing I want to talk about in terms of enums, since I mentioned the Boolean type, I also show that in the Scala cookbook in recipe 6.13. So this is the online version of the Scala cookbook. It's on the O'Reilly Learning platform. And I don't want to get too much into algebraic data types right now, but what I do want to do is scroll down here, and this is what I was talking about. So I showed the Boolean type earlier, and this is how you create that enumeration. And again, a Boolean just consists of true and false values. And skipping past everything else here, the first thing I show is that you create a case class, and it takes two Boolean values. So it takes B1, which is a Boolean, B2 is a bool. And this particular example has to do with product types. So what I do here is I enumerate all the possible versions of the double bool function. So it can take true, 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 false, false, true, and false, false. And that's just kind of a start of how to use your own Boolean type. And then if we scroll down here, I show more operations that you can do. So again, here's the enumeration. I import the enumeration right here, as I did before. And then I show how to create two functions. This one is called and this one is called or. So both of these take in two Boolean values. And the and function says, I'm going to take in these two Booleans. I'll return a Boolean. And one thing I do different here that I haven't shown before, I think, in this course, is that I turn these two parameters into a tuple. So again, this is a two-element tuple, and it's these two Boolean elements. So then I call a match expression on this tuple value here. So then what I show in this first case is that for AND operations, if you give me two true values, then I will return true. And I could make this code shorter, and I might do that later in the book. I don't remember. But all these other conditions are going to be false. So if you give me two false values, that's going to be false. If you give me true false or false true, those are also going to be false. So this shows how you implement the AND function using a match expression. And then I show a couple examples here. So if you give me true and true, I'll return true. And if you give me anything else, if I enumerated all these possibilities, you'd see false for all the others. And here I did take the shortcut. So I say if you give me a true along with anything else for the second parameter, really that would just be false. I'll return a true here. And then disregarding this first parameter, if you give me a true for the second one, that will also be true. And then for the third case, I say if you give me anything else, yeah, really that's just going to be false and false, then I will return false here. So for this particular example, I just wanted to show more fully how to use a Boolean. So again, you create the Boolean, you import it, and then you create your functions however you need to. You can pass in your new type, the bool type, as input parameters, and you can also use it as a return type from your functions. And then you can use the enumeration values, which are in this case are true and false, inside the function, as shown in these two examples.